All right, so this is practice test one, exercise three, right? They give us four vectors, v1, v2, v3, v4, and they ask, do these four vectors span all of R3? So in other words, can I generate any vector within R3 using these four vectors, right? So how can I tell if these vectors or any vectors in general, right, span like some Rn, right? So how you can do that is, well, you need to check to see if every row has a pivot, right? So let's sort of like take this as an example matrix, right? So I have 1, 0, 0, say like I'll say like 2, 1, 1. Actually, no, I'll take 2, 0 or 2, 1, 0, and I'll take like we'll take this as like 3 and then like your 0. And then, since we're dealing with four vectors here, I will use something like this, right? So let's take this as an example and see if this spans all of R3, right? So first, I just want to identify that we have three pivots here, right? So in row one, I have a pivot right here. In row two, my first non-zero entry is this one, so he's my pivot. And then in row three, right, my pivot's down here, right? So what I have is a pivot in every row, and I'm tasked with finding out if these four vectors here span R3, right? Why is it R3? It's because there's three components in each vector, right? So every vector here has three components, so we're in R3, right? So let's augment this matrix with the vector A, B, C, where A, B, and C are all real numbers, right? So let's try, I guess, and solve it, right? So, or just like kind of look at it conceptually, right? So if I have this equation here, right, 2x4 is equal to c, right? Let's actually write it down. So 2x4 is equal to c, then x4 is equal to c over 2, right? Okay, so that's that. For our next equation, right, what do we have? Now, I should also know here that we actually have a free variable here because this column x3 doesn't have a pivot. It doesn't have its own pivot, right? So I can just say right here that x3 is equal to some t, right, where t is a real number, right? Okay, so now what do I have here? I have an equation of one variable. Why do I have an equation of one variable? Is because x3 I just found it, right, and x4 I found it from this bottom equation. So it's an equation of one variable, right? So I have x2 plus 3, like say t, right, and then plus it's going to be 1x4, so c over 2 is equal to b, right? So that's a system, or not a system. It's an equation of one variable, right? So what I'm going to do is I'm just going to subtract these two, and then I get x2, right? And then I go to the top equation, and I'm really just trying to find x1, right? Because I already know past this point what x2 is. I know what x3 is, and I know what x4 is, right? So in other words, I have a consistent system because I had a pivot in every row, right? So if that's the case, what does this look like if I don't have a pivot in every row, right? Because we just said if I had a pivot in every row, then I'm consistent for any vector that I throw at this matrix, right? Any vector that I decide to augment with this matrix. So what happens if this turns into a zero, right? Well, what happens is that I don't know if this is going to work. What happens is that you enter this form, 0, 0, 0, augmented with like some non-zero number, right? So you get like 0, 0, 0, augmented with c, right? So in other words, we get an inconsistent uh, matrix, right? We get an inconsistent like system of equations. That's really bad because what I'm trying to do is represent every single vector in R, in this case, 3, right? So what if I try to represent with these vectors? What if I try to represent 1, 1, 1, right? I can't do it because this row right here would be 0, 0, 0, 0 instead of C would be 1. right? Because these would all be 1. This is inconsistent, right? You would never find a solution to this. In other words, you would never be able to generate the vector 1, 1, 1 with these sets of vectors, right? So now, what is my goal? How can I find if a set of vectors span, let's say in this case, R3? You would need to check and see if you had 3 pivots, right? If you have a pivot in row 1, in row 2, and row 3, you would need a pivot in every single row, okay? So with that idea, let's go ahead and solve this question, right? They give us 4 vectors with actual numbers in them, right? Instead of like variables or whatnot, right? So I have the matrix here. So what we have to do is we have to throw each one of these vectors into a matrix, perform row operations so we can identify those pivots, and then see does every row have a pivot, right? So what are we going to do here? We are just going to we want to eliminate this 2 right here. So how do I do that? I just say that row 2 is going to be assigned to 2 row 1, and then we're going to add row 2, right? Because if this is 2, then 2 minus 2 is equal to, well, I really should have said 2 plus minus 2 is equal to 0, but you get the point, right? So we're over here. We're not changing row 1. We are changing row 2 though. So I'm gonna multiply this by 2 and then add it to this guy. What do I get? I get a 0, because if I got anything else, then something's wrong, right? Then 2 times this plus that is 4. 2 times this plus that, it's also 4. And then 2 times 3 gives you that 6 minus 2 is going to be, well, 4, right? And then this last row is going to be 0, -1, -1, 1, right? So then what's our next row operation? What do we have to do? So we already got our pivot kind of cleared here, right? Because row 1 had this pivot, so I had to get zeros here. And now where's my second pivot? I look at row 2 and I find this 4, right? That's my second pivot. So what I have to do is get a 0 right here. Now, what I could do is I could take row 2 minus, or I guess like plus 4 times row 3. Well, what I'd like to do is, because I have all 4s here, I can just kind of reduce that down, right? So I can say that row 2 is I guess like transformed into row 2 divided by 4. Right? It just makes it a little easier to look at. It's a totally unnecessary step. You can go right into the elimination if you'd like. This just makes it look easier to me, right? So now it's a simple, right? This row 3 gets turned into row 2 plus row 3, right? I can write that a little better. Plus row 3, right? Might be running out of space here, but we'll be fine. So then, yeah, row 2 and 1 stay the same, and then row 3 has to change, right? So I just have to add these 2 numbers. Get 0, you get 0, and then you get like a 2 here, right? So with that, we had to identify some pivots, right? So let's go ahead and look at row 1, right? We had a pivot right here, right? That's why we cleared out this column, right? So this is a pivot in row 1. So far so good, right? But I mean, what matrix isn't going to have a pivot in row 1 besides the 0 matrix? But that's besides the point, right? Row 2 has a pivot right here, right? And I cleared it out, right? So you have a pivot, right? Okay, so now if this is truly going to span R3, I need a pivot down here, right? So do I find it? No, 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 yes, right? I did find a pivot in every single row, right? So that means if I augment this with like any vector A, B, C, I'll always be able to find a solution. In other words, I will be able to generate any vector in R3. In other words, I span R3 with these 3 or 4 vectors, right? And that's just because I had a pivot in every single row. It doesn't really matter that I didn't have a pivot in this column. All it really tells me is that these vectors are not linearly independent, right? Because I can take a linear combination and actually create this vector, right? So I have a free variable, but that a free variable doesn't really tell you if you can or cannot span um, some dimension, right? What tells you that is if you have pivots in every row, not column, right? If you have a pivot in every column, that's cool too, but like we're just concerned about the rows, right? So I hope that helped.